Hey Blue Mountain 5th graders, the topic for today is Euler's totient function. Euler was a mathematician who was alive in the 1700s. He was super smart. He was definitely one of the best mathematicians ever. One of the things that he discovered is something called the totient function, which is also called the phi function. The totient function has two different symbols. One symbol looks like this, the other one looks like this. I like using this one because I just think it looks cooler. The totient function is based on a concept that's called co-prime. You know what prime numbers are. Prime numbers are things like 17 or 11 or 29. Numbers that only have two factors, 1 and itself. So the only two numbers that can divide into 17 are 1 and 17. The same is true for 11 and 29. When we talk about numbers that are co-prime, that means that they don't share any factors other than the number 1. So let's look at the number 10 and the number 15. These are not co-prime because they share the factor of 5. 5 fits evenly into 10, and 5 also fits evenly into 15. So 10 and 15 are not co-prime. If you look at numbers like 12 and let's say 13, the only numbers that fit into 12 and 13 would be 1. So 1 fits into 12 and 13. 12 has some other factors, but those factors do not work for 13. So 12 and 13 are co-prime with each other. So let's try an Euler's totient function problem. If we try to find Euler's totient function of the number 12, the first step is to list all of the numbers from 1 through 12, all of the whole numbers. So 1, 2, 3, 4, we continue all the way up through the number 12. The next step is to circle the number 1 and to cross off the actual number. If you would cross off the 1 and circle the actual number, you'll see that you would actually get the same answer as well. Now, we need to look at each number and see if each number is co-prime with the number 12. If the number shares any factor with 12 besides the number 1, then it is not co-prime. So let's start with the number 2. 2 has a factor of itself, which is 2, and 2 is also a factor of 12. 2 fits into 12. So 2 and 12, since they do share a factor of 2, they are not co-prime. Since they're not co-prime, we'll cross off the number 2. The number 3 has a factor of 3, which is also a factor of 12, so they are not co-prime either. The same thing is true for the number 4. 4 fits into 4 and 4 fits into 12. Also, 2 fits into 4 and 2 fits into 12. When we look at the number 5, the only number that goes into 5 and also goes into 12 is 1. Since that doesn't count, that means that 5 is co-prime with 12, so I'm going to circle that one. 6 has a factor of 6, which is also a factor of 12. In fact, 6 has a factor of 2, which is also a factor of 12. That tells us that I can cross off all even numbers because all those even numbers share the factor of 2 with 12. The number 7. 7's prime, so the only numbers that are factors of 7 are 1 and itself. 1 doesn't count, I circle the 7. When you look at the number 9, at first you might think 9 and 12. 9 doesn't fit into 12, so you might think that they are co-prime. But when you think about it a little more, you'll realize that 3 is a factor of 9, and 3 is also a factor of 12, so they are not co-prime. And 11 is co-prime with 12, because this is prime, and so it's co-prime with 12. When you look at this list of numbers, you'll see that I have 4 numbers circled. So Euler's totient function of 12 equals 4. All you have to do is count how many numbers were circled. So that would give us an answer of 4. So if you're at the grocery store after the quarantine and somebody goes up to you and says to you, hey, what's Euler's totient function of 12? You can just tell them it's 4 because you've already calculated that one. Let's look at Euler's totient function of a prime number. Let's look at Euler's totient function of the prime number 7. So for this, we have to write the numbers 1 through 7. Circle the 1, cross off the 7. When you look at each number, does 2 share any factors with 7? Well, 1 goes into both of them, but that doesn't count. That's the only number that is a factor of both, so that would get circled. How about 3? Do any numbers go into 3 and 7? No, so they're co-prime. And the same thing is true for 4, 5, and 6. Since this is a prime number, it does not share any factors with the rest of the numbers on the list. So Euler's totient function of 7 equals 6. If you think about that a little more carefully, you'll realize that Euler's totient function of any prime number, if we do Euler's totient function of 23, that would equal 1 less than the number because you cross that number off of the list, so that would equal 22. You can figure that out without even doing any kind of work. One thing I think is really, really interesting about Euler's totient function is that, as you saw in the beginning of the video, he was alive in the 1700s. He was alive more than 200 years ago. And his totient function that he figured out is actually used for computers today. The Euler's totient function helps computers be more secure. So if your parents are doing anything with their bank online, or you're ordering something, ordering a book from Amazon or something like that, all of those money transactions are secure, partly because of Euler's totient function that he figured out all those years ago. So it's still being used today. All right, thanks for watching.